Hello, my name is Jeremy Dilts, and I would like to talk to you about brain-machine interfaces today. I would like to talk to you about what brain-machine interfaces are, why it needs to be researched, who is researching it, who it can help, and a few other things that are very important about brain-machine interfaces. A brain-machine interface is quite simply what the name states, an interface between a brain and a machine. Now, the brain can be either a monkey brain, a rat brain, or a human brain. The machine can be either a robotic arm, a robotic leg, the internet, a computer screen, or any other electronic device. Why brain-machine interfaces need to be researched is quite simple. Many people have lost the use of their legs and arms due to injuries or neurodegenerative diseases. Brain-machine interfaces have the ability to help these people walk and move around once more. One of the leading proponents in brain-machine interface technology is a doctor named Miguel Nicoleles. He's from Brazil, and he wrote a book called Beyond Boundaries, in which he chronicles his research on the cutting edge of brain-machine interface technology. Brain-machine interfaces can help many people with spinal cord injuries and neurodegenerative diseases. These people have lost the use of their limbs, the ability to speak, the ability to feed themselves, as well as other important and or simple things. The reason brain-machine interfaces are so important to people with disabilities like neurodegenerative diseases and spinal cord injuries is because it will give them back freedom, mobility, and self-sufficiency. They will not have to rely on others to simply go to the bathroom or drink a drink. The brain-body connection is very important when talking about brain-machine interfaces. The brain-body connection allows the brain to send electrical systems through the nervous system to move limbs. It also allows your limbs and organs and sense organs to transmit signals to the brain so that you can sense your surroundings. Recording brain signals is a very complex task. Most of the time it involves drilling into the brain and placing a sensor at the correct spot to record neural impulses or the electrical signals that brain cells make. Doing this has the potential to damage the brain. Bypassing nerves is the key to brain-machine interface technology. Bypassing nerves has been done with cochlear implants that allow the hearing impaired to hear. Now, bypassing damaged spinal cords or nerves in arms and legs is a totally different story. It's much more complex. The current state of brain-machine interface technology is in its infancy. There are two different kinds of technology in use currently. There's the in-brain technology where you drill into the brain and implant a sensor, and then there's over-the-brain technology where you put sensors on the skull. Connecting brains to robot limbs is a matter of getting software and hardware to work together and is an extreme engineering challenge. The technology of getting sensors to record brain activity correctly is still very new and unproven. More research is necessary to create better interfaces. Current brain-machine interface technology has proven very hopeful with the use of monkeys. Miguel Nicoleles has created and tested a machine that allows a monkey to use a robot arm to feed itself by using its thoughts only. This is very exciting technology. A mouse brain-machine interface was used to complete DARPA's Maze Challenge for robotic systems. The mouse blew the competition out of the water. The next closest contestant's time was measured in tens of minutes compared to the mouse's time. Another technology competing with brain-machine interfaces are called power suits. As you can see, they can do similar things and restore mobility to the paralyzed, but not everything. They cannot bypass dead nerves and give control back to otherwise paralyzed limbs, or give back a sense of touch. One of the largest problems with power suits and robotic limbs is the power source. Battery technology has not changed much in the past 10 years, leaving power sources large and bulky. This is not an ideal solution to helping the paralyzed regain mobility. Another possible outcome of brain-machine interfaces is called full body prosthesis. This is where the brain is put into a fully prosthetic body. Think RoboCop or Ghost in the Shell. But brain-machine interface technology has the potential to make this a reality for many people who suffered. The economic impacts of brain-machine interfaces, I believe, will be good. Brain-machine interfaces will create a job market for highly skilled workers. It will also push the limits of our current technological capabilities, creating markets out of a combination of current technology that are not linked now. What I want to encourage you to do now is watch this simple 4-minute video on bigthink.com. Watching what such a simple thing as drinking a cup of coffee without the aid of another human being will, I hope, show you the power and impact brain-machine interfaces can have on a single person. The military applications of brain-machine interfaces can be a double-edged sword. Hooking the brains of soldiers up to remote combat systems will, without a doubt, save soldiers' lives. But what happens when it's only remote combat systems fighting each other? What are the more ramifications of using remote combat systems? At this time, I don't know. The future of brain-machine interfaces at this time seems endless. From the restoring of movement and senses to paralyzed limbs to full-body prosthesis to even the possibility of uploading your mind into a robot body. The only limitation to this technology is simple: the power of our minds to imagine the future.